Welcome back to Chem Talks. In today's video, we are going to continue talking about what we talked about last time. That was dimensional analysis. Only in today's video, we're going to add one more step. Rather than converting a single unit in a problem like meters to feet or grams to moles, we're going to do two units. Okay, so we're going to be doing multi-factors in this unit. Same thing as you did last time, except we have to do two problems or two conversions within the same problem. Okay, so multi-dimensional analysis just refers to converting more than one unit in a problem. Examples of this could be converting miles per hour to kilometers per hour, grams per milliliter into moles per liter. So there's two units that we need to convert. We do the same process of setting up conversion factors, canceling out the units until we get what we want. Okay, so in these multidimensional problems, both the numerator and the denominator are being changed within the same problem. Okay, that's what makes it multidimensional. We have two factors. Okay, but the big thing to remember is it follows the same procedure that you used last video with doing single factor dimensional analysis. Same thing, nothing new. We just added one or two steps, kind of like that homework we had last time. They get on converting years to minutes. It adds a little more in it. The key to doing this is to work one unit at a time. If we're doing miles per hour, convert miles to kilometers, and when you're done with that, convert hours to whatever unit you're going in. All right, same 5 steps as last time. If you didn't get these copied down last time, make sure you pause it at the end of this slide, and copy them down. First, start with what you're given in the problem. Write down what you know. Okay. Secondly, figure out what you're solving for, and then create your roadmap. Use these conversions to get from the known to unknown. I will generally start with whatever my value is or my unit is on top, convert that, and then switch to the bottom unit and convert that. It's all done in one problem, so don't break it up into different problems. Okay, then make sure as you go along you're canceling your units to make sure you end up with the correct one, and then finally do the math. So if you didn't copy this down last time, pause the video here and copy them. Okay, let's do 2 practice problems. It's nothing new, so we're really new. So we're just going to do a couple of them. First example, convert 75 mph, which is miles per hour, to kilometers per minute. Okay, the first thing we need to do is to get rid of that mph. We need to write the values as a fraction. So 75 miles per hour, we would write 75 miles over 1 hour. Okay, that p, the per, is our slash line. So it's 75 miles per hour. Kilometers per minute is going to be km/minute. Okay, the reason we put the question mark is that's what we're trying to figure out. So let's set this up. Okay, remember we start with our ping pong table, our factor labeling table, and we start with what we know. We know we have 75 miles per hour. Now there are multiple steps, as we talked about last time, that you can take to do this, okay, as far as conversions. I'm going to show you one. If you have another one, great, use it. Your answer might be slightly different than mine, as we already talked about. So first thing I'm going to do is I'm going to go from miles to kilometers. And I know that in 1 kilometer there are 0.62 miles. Now I put what I want to cancel on the opposite side. We said before it was at the bottom. Now we're talking about opposite sides, which in this case does happen about. So in this case, our miles cancel out and we're left with kilometers. Okay, that's one of my values. Now the other thing I have to do is convert from hours to minutes. Okay, well I know that in 1 hour, now I'm going to put this on top this time, even though it's what I want to get rid of because it's the opposite side as what I'm getting rid of. Okay, and I know that in 1 hour there are 60 minutes. The units we're canceling don't have to be right next to each other in the problem. You can see we have the kilometers / miles in between, and that's okay because our hours, since they're in opposite sides, still cancel out, and I'm left with a unit of meters. So now I have kilometers per minute. Excuse me. Now I'm going to take 75 times 1 times 1 equals, divided by 0.62 equals, divided by 60 equals, and I come up with an answer of 2.02 kilometers per minute. Same thing we did with single factor dimensional analysis, except this time we have two. We solve for one unit, and then we go ahead and solve for the other unit. Remember, as we do the math going across our table, as we go across, we multiply. When we have top to bottom, we divide. Okay, let's try another one. Let's go back to one of my favorite movies as a kid, Indiana Jones and the Raiders of the Lost Ark. Maybe you guys remember this scene. Very beginning of the movie, Indiana Jones is going after the golden idol head, and he knows it's booby-trapped. So he has to take off the head and put the sandbag in so he doesn't set it off. Well, let's see if Indy got it right here. Now, if we look at that golden idol, it's about the size of a 1 liter bottle, Nalgene. Okay? So we're going to assume the volume of that is 1 liter just for the sake of doing this problem. Now, if I look gold up, what I find is gold has a density of 19.3 grams per milliliters. Okay, that doesn't mean a whole lot to us generally. We're more familiar with pounds. So why don't we change this to pounds per liter? We said the head's about a liter. Okay, so if the head was about a liter in volume, a size, okay, how much would it weigh? So we start with what we know. Well, we know the density of gold, and that's 19.3 grams per milliliter. So I have to convert grams to pounds and milliliters to liters. I always like to start with what's on top. So for this one, first step I'm going to do is I know that 1 kilogram is equal to 1,000 grams. So my grams cancel out. Why did I choose that? Well, I know there's a good conversion between kilograms and pounds from our conversion sheet, which you don't have to have memorized. Okay. Now I want to get rid of kilograms, so that's going to go on the bottom. So 1 kilogram is equal to 2.2 pounds. My kilograms cancel out, and now I'm left with pounds. Okay, I'm halfway there. Now I have to go from milliliters to liters. Remember, with metric units, I have to memorize them. I know that in 1 liter, there are 1,000 milliliters. I put the milliliters on top because I want them to cancel out. So even though they're not next to each other still, the milliliters cancel out. So now I do my math. I take 19.3 times 1 times 2.2 times 1,000 equals, divide it by 1,000. And I come up with an answer of 42.46 pounds. So Indy, in order to keep that booby trap from going off, had to put 42.46 pounds of sand in that little bag. Looking at the size of the bag, somehow I don't think he got it right, which is why the big ball fell and came and chased him, and we started the Indiana Jones trilogy. But you can see, once again, we worked through our first value, and then we went to our second value. Pretty easy. It's the same step. We just have to do 2 of them. Remember, as you go along, cancel your units out. When you get to your correct unit, circle them as we did here in red. That will help you guys make sure you're getting the right units. Because remember, if you don't get the right units, bad things happen. Bad math happens, and we don't want that to happen. All right, guys. Till I see you in class. Take care. Practice this.